In a normal set theory, we know that A intersection complement of A is an empty set phi and A union its complementary A dash is the universal set X. But it is not true with fuzzy sets, and this is because in fuzzy sets, in my earlier videos, we have seen that reality is not sharply defined. Therefore, for a fuzzy set, A intersection A dash is not equal to an empty set phi and A union A dash is not equal to the universal set X. This can be easily understood from a simple example. For a fuzzy set A defined on universal set X with grade values from 0 to 1, if A of X is 0.3, then according to rule, A dash X will be 1 minus A of X 1 minus 0.3 0.7. We observe that since A of X and A dash of X contain at least one element, therefore A intersection A dash is not an empty set phi and A union A dash is not the universal set X. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. In this video, we are going to study algebraic operations on fuzzy sets. Most commonly used algebraic operations on fuzzy sets are standard complement, standard union, and standard intersection. Let A and B be two fuzzy sets on a same universal set X. Then the fuzzy set A dash or A bar, which is complement of A, defined as A dash or A bar on X with grade values from 0 to 1, then A dash X or AX bar is 1 minus A of X is called standard complement of A. Next, under the same conditions, the fuzzy set A union B on X defined as A union B defined on X for grade values from 0 to 1, A union B of X is maximum of A of X and B of X is called standard union of A and B. And finally, the fuzzy set A intersection B on X defined as A intersection B on X for grade values from 0 to 1, A intersection B of X is minimum of A of X and B of X is called standard intersection of A and B. Let us understand these operations by actually solving a few examples, graphically and analytically. We will see how to illustrate complement of A, which is A dash or A bar, union of A and A bar, and intersection of A and A bar. First, we will graphically illustrate fuzzy set A. This is illustration of fuzzy set A. We have discussed at length in my previous videos on fuzzy sets as to how to illustrate a given fuzzy set graphically. Its complement A bar can be represented as like this. So this is complement of A bar. We have seen union of A and B of X to be maximum of A of X and B of X. This can be shown by superimposing fuzzy set A bar on fuzzy set A. So A bar will be maximum of AX and BX, which can be shown by this upper part of the diagram marked in red ink. We have seen A intersection BX to be minimum of ax and bx, and this minimum can be shown by this lower part of the diagram. So this is A union B marked by red ink, and this is A intersection B marked by blue ink. We will take another example. Fuzzy set A is defined by a parabolic function like this, and another fuzzy set P is defined by a trapezoidal function as shown here. In order to find their union, we will superimpose B on A, and as we know, A union B of x is maximum of AX and BX, which will be this upper part marked in red. So this is A union B marked in red, and as we know, A intersection BX is minimum of A of x and B of x, which can be represented by the lower part of this superimposition, this one marked by green. So this green part is A intersection B. So this is how we can illustrate A union B and A intersection B, that is union and intersection of two fuzzy sets A and B. The expressions in this inset have been written according to the rules that we have just understood. Now we will solve a problem based on these rules. Let the fuzzy sets A and B are defined by the following membership functions. A is 0 upon 1 plus 0.2 upon 1.5, 0.35 upon 2 plus 0.15 upon 2.5 plus 0.5 upon 3, and B is defined as 1 upon 1 plus 0.15 upon 1.5 plus 0.2 upon 2 plus 0.35 upon 2.5 plus 0.4 upon 3, where the denominator indicates members from the universal set X and the numerator corresponding membership values of these elements. We have to calculate A intersection B bar union A and A union B whole bar. Since there is B bar here, we have to find B bar, which will be according to this rule 1 minus 1 0 upon 1 plus 1 minus 0.15 0.85 upon 1.5 plus 1 minus 0.2 0.8 upon 2 plus 1 minus 0.35 0.65 upon 2.5 plus 1 minus 0.4 0.6 upon 3. Next we will find this A intersection B bar, which according to this rule will be minimum of this A and this B bar. So A intersection B bar will be minimum of AX and B bar X. That will be between 0 and 0. 0 is minimum upon 1 plus between 0.2 and 0.85. 0.2 is minimum upon 1.5, etc. plus 0.5 upon 3. Next we have to find A intersection B bar union A, which according to rule is maximum of A union B bar of X and A of X. So maximum of A intersection B bar, this one, and A, this one, which will be maximum between 0 and 0 is 0 upon 1 plus maximum between 0.2 and 0.2 is 0.2 upon 1.5 plus maximum between 0.5 and 0.5 0.5 upon 3, which is nothing but fuzzy set A itself. This is according to absorption law, which goes like this: A union A intersection B is same as A intersection A union B, which equals fuzzy set A itself. Given two fuzzy sets A and B, A of x is 0.6 upon x2 plus etc. plus 0.1 upon x6. b of x is 0.7 upon x2 plus etc. plus 0 upon x6. We have to find number 1 a bar, number 2 a intersection b bar, number 3 a bar intersection b. In the questions there are a bar and b bar, so we need to find a bar x and b bar x, and a bar x is, according to above definition, 1 minus a of x, and from this we directly write the answer to the first question. A bar equals, from this a of x, 1 minus 0.6, 0.4 upon x2 plus 1 minus 0.8, 0.2 upon x3 plus etc. plus 1 minus 0.1, 0.9 upon x6. Next we write b bar x, which is 1 minus b of x, from which we write b bar equals 1 minus 0.7, 0.3 upon x2 plus 1 minus 0.5, 0.5 upon x3 plus etc. plus 1 minus 0, 1 upon x6. Now we have a intersection b bar x equals minimum of a of x and b bar of x. From this we write answer to the second question a intersection b bar as, from ax and this b bar, minimum of 0.6 and 0.3, 0.3 upon x2 plus minimum of 0.8 and 0.5, 0.5 upon x3 plus etc. plus minimum of 0.1 and 1, 0.1 upon x6. Now for the third answer, a bar intersection b, we need a bar intersection bx, which is minimum of a bar of x and b of x. Therefore, answer to the third question, a bar intersection b, from this a bar and this b, will be minimum of 0.7 and 0.4, 0.4 upon x2 plus minimum of 0.5 and 0.2, 0.2 upon x3 plus etc. plus minimum of 0 and 0.9, 0 upon x6. Now we have all the three answers: a bar, a intersection b bar, and a bar intersection b. Let fuzzy sets a and b defined on x equals 0, 1, 2, 3 and 4. Great value a of x is x upon x plus 1. Great value b of x is 1 minus x upon 10, that is 10 minus x upon 10 for x belonging to universal set capital X. We have to find number 1 a bar union b bar, 2 a intersection b bar, 3 a intersection b whole bar, 4 a bar intersection b, 5th a bar union b. A of x is x upon x plus 1, which we write 0 upon 0 plus 1, 0 upon 1, 0, 1 upon 1 plus 1, half, etc. and 4 upon 5. For comparison purpose, we write them in decimal form: 0, 0.5, 0.66, 0.75, 0.80. A bar of x is 1 minus x upon x plus 1, 1 upon x plus 1, which will be 1 upon 1 plus 1, 1 upon 2, 1 upon etc. and 1 upon 5. P of x is 10 minus x upon 10, which will be 10 upon 10, 10 minus 1, 9 upon 10, etc. and 6 upon 10. For comparison purpose, we write them in decimal form: 1, 0.9, 0.8, 0.7, 0.6. P bar of x will be 1 minus 1 plus x upon 10. It will be x upon 10, hence 0 upon 10, 1 upon 10, etc. and 4 upon 10. Before we proceed, let us write a bar x in the decimal for the sake of comparison. So it will be 1, 0.5, 0.33, 0.25 and 0.20. Similarly, we will also write b bar x in the decimal form 0, 0.1, 0.2, 0.3, 0.4. Now we will solve the first question. We have to find a bar union b bar. We know that a bar union b bar of x is maximum of a bar of x and b bar of x. Accordingly, we write a bar union b bar as from these two 1 upon 0 plus 0.5 upon 1 plus etc. 1/3 upon 2 plus 0.4 upon 4. From this De Morgan's law, a bar union b bar equals a intersection b whole bar. From this law, we write answer to the third question a intersection b bar, which will be a bar union b bar, same as what we have just found out, 1 upon 0 plus half upon 1 plus etc. plus 0.4 upon 4. Now we will write answer to the last question a bar union b bar, for which we have a bar union b of x is maximum of a bar of x and b of x. For this, we have to focus on these two sets, this one and this one. And now we will directly write a bar union b equals 1 upon 0 plus 0.9 upon 1 plus etc. plus 0.6 upon 4. So that completes answer to all the 5 questions. Viewers, if you like this video, please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. See you in the next video. Until then, keep watching Number Collage. Thank you.